Hey everyone, welcome back to another iBuddy math video. Today we're covering completing the square. This method allows you to solve any quadratic even when factoring doesn't work, and it also puts the equation into vertex form, which allows you to exactly pinpoint where the vertex of your parabola is. Two birds, one stone, making it way easier to graph parabolas. Now, you should only use this format when you need that vertex, since this is quite a bit slower than the quadratic formula and factoring. Let's get into it. So first, why is it called completing the square? Take this expression for example. X squared plus 6x. There's no constant, so we can't factor it. We can't really factor it properly. But if we figure out the right number to add, we can turn it into a perfect square trinomial and then factor it. Here's the trick. Take this middle number, 6, divide it by 2, giving you 3, and then square it, giving you 9. X squared plus 6x plus 9, which just becomes x plus 3 squared, which factors, But here's the important part. You can't just add the 9 out of anywhere. You can't do that in math. That would change the whole expression. So you instead rewrite it as, over here, x squared plus 6x plus 9 minus 9. Do it like that. And then get the minus 9 out here. Now this, you get your answer like that. It's quite simple. And then you get your vertex of -3 and -9. Let's do a complete example that you can find on any text. For example, you get x squared plus 6x plus 7. Now, we can move the 7 to the side and just focus on it like this. X squared plus 6x plus c minus c plus 7. Not plus 7, minus 7. We can now start working with that. So you do the same thing we did before. X squared plus 6x plus 9 minus 9 minus 7. And then you can factor it, x plus 3 squared. But you have to bring out this 9 over here. So you got minus 7 minus 9. Don't forget equal signs. X plus 3 squared minus 16. Now, that is vertex form. X, H, and K. So then we can also find the vertex, which is -3 and -16, which will make it infinitely easier to solve for your parabola. And as we now know the lowest point of our parabola. Now, if we want to solve for x, you have to set this to 0. So x plus 3 squared minus 16 equals 0. X plus 3 squared equals 16. X plus 3 equals plus minus 4. X would equal 1 or -7. Two solutions, and you can always verify these by plugging them back into the equation. But just like that, you have both your x-intercept and vertex from the same equation. Now, what we have to try before you guys go, try this on your own because this is essential. And it is extremely essential to anything we do here. It is when the x squared term has a coefficient that isn't 1. So for example, 3x squared plus 12x minus 6. Now, what do we get from this? You will have to factor out the 3, of course. But you should only factor it from these two terms, the ones which are underlined. You get 3x squared plus 4x. Keep that minus 6 on the outside. What you would do is keep going. Plus 4x plus c minus 6 equals 3 times x squared plus 4x plus 4 minus 6 equals 3x plus 2 squared. But that -4, when you take it out, you have to multiply it by that -3. You would get minus 12 minus 6. You do that, you get 3 x plus 2 squared minus 18, vertex -2, -18. So the most important step that we just did there is when you take out that minus c, you have to multiply it by the 3, resulting in that. And then you have to, and that's how you have to do it, or else your answer will be wrong and you will lose many, many marks. So essentially, the only difference when the x squared has a coefficient is that you have to factor out, but you don't factor like you normally would. You factor a part of the equation, and then at the end, you have to multiply what you factored out. But there is a way to do this without with factoring the whole thing, but we're not going to be going over that today. So let's zoom out for a second. When you complete the square, you're converting a standard quadratic. As you can see, we have the standard quadratic A, B, C, which you would use in the quadratic formula. X equals blah, 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 right? But now you're completing the square, which is essentially changing it into vertex form. Vertex form, which is y equals a times x minus h squared plus k. That's what you're doing. Vertex form gives you 3 things instantly, which is the h and the k, the axis of symmetry, which is the h value, and because the coefficient of the bracket is positive, in this case, the 3, it tells you which direction the parabola opens up. If this was negative, you know it's opening down, meaning that your vertex is the minimum point in this instance, but if it was negative, it would obviously be the maximum. That's why this method is so useful. You're not just solving, you're understanding the shape of the whole parabola. And parabolas are essential for all. So, just a quick recap. Take the middle number, divide by 2, square it, that's your c value, write plus c minus c. Group the perfect square. Simplify if the x coefficient is there. Factor it out. Now, unlike regular factoring, you will factor out the x even if it's not perfect for the rest. Let's say if it's 5x squared plus 13x, you will still factor out that 5. You will just get 13 over 5. You cannot have anything attached. You should not have anything attached to your x squared term. There's worksheets on the site if you want to practice, and if anything's clear, drop it in threads. That's our forum where you can ask questions and get answers from tutors and other students. Links are in the description. See you in the next one. And just before you leave, I'll just write 2 practice problems for you, which are slightly challenging. X minus 10 equals 0. 4x squared plus 16x minus 20 equals 0. Now, if you want to try and find the vertex of these using the completing the square law. It's essential, and goodbye.